Anyway, we've got to the point now where we've got to an RDD containing just what we think are interesting words. Job now is to count them. We did exactly this in the previous chapter where we built a pair RDD where the keys are the words and the values are just the simple value of 1. And then we can run a reduce on that pair RDD where we sum up the values, but we do it by reducing by key. If you need any information on that, check the earlier chapter on pair RDDs. So I can go quite quickly through this. We've got our just interesting words, and we want to map it to a pair RDD. And given a word, we want the elements of the pair RDD to be one of these horrible, well, horrible in Java, tuple 2s, where we're going to have a string as one value and a long as the other value. And the string is going to be the key, which is going to be the word, and the value will be just the value 1 expressed as a long. So that's going to give us a Java pair RDD where the types are string and long. I'll just call this one pair RDD because I'm running out of inspiration. Now I need to import Java pair RDD. That's good. Now I just stopped recording them because I have a compile error here which had me scratching my head for quite a long time. If I hover over this, it's clearly, well, it appears to be a problem with types. It won't let me hover over it now. It says there's a type mismatch here in that it can't convert from Java pair RDD object to Java pair RDD string comma long, which is very confusing. And I think this is the sort of thing that does put people off who are new to Java 8 functional programming. Often the compiler will really mislead you. Let's just check everything here. I'm saying that I'm expecting a Java pair RDD keyed with strings with the value of longs. And I'm calling map to pair, and it looks exactly the same as we did previously. And we know that if we return a new tuple 2, and as long as we type this correctly, a string and a long, then the resulting type of the pair RDD will be string and long. I promise you this is correct, but the compiler is trying to tell me it's not correct. It's saying the types are wrong. And I've tried cleaning, I've tried smashing my fist into the keyboard, not really, but you probably would do after a few days of being stuck on this. And it's a red herring. It's purely the compiler not being very helpful. All that's happening here, I've got to hover over the right place basically. If I hover here, it's just saying I've not imported tuple 2. And the fact that tuple 2 is not imported means it can't parse this. So it's just saying, well, I don't know what types are going to be in here. So, yeah. Well, all we have to do is fix the underlying problem, which if we import tuple 2, then the compiler now knows that, yeah, you're working with string and long, and that matches what you have here. Yeah, I have nothing to say about that other than that's the kind of thing that does put people off Java. Sorry about that. On behalf of the compiler, I apologise to the world. Anyway, we now have our pair of key and the number 1. And let's output it just to make sure it's working. So now after changing pair RDD to here, in fact, now the type of this is incorrect. This is a genuine error this time. We were always working with just strings as each value, but now when I do this take, it's going to return 50 of these tuple 2s. So again, this is where this tuple 2 business gets a little bit sticky. The type here is not string anymore. The type is tuple 2, which itself has a type of string, comma, long. And I'm assuming here that when I do a print line for each of the tuples, there will be a good to string implementation for the tuples. Let's see what we get. Yeah, that's fine. That's the kind of output that we expect. I can see there's one instance of this bad data where we've just got a blank, and there's another instance there. So it does look like possibly the word count of this is going to end up in the top 10. Let's see. Anyway, the next step then is to run a reduce by key to add up all of those ones. So we're going to take our pair RDD. Again, if you're struggling here, then check the earlier chapter on how to work with pair RDDs. But we're going to do a reduce by key, which will map together the keys. And then for each key in turn, we'll run the function where we take any two values, add them together, and Spark will keep doing that until we get a single value. So that's going to be another pair RDD with string and long, but now the longs won't be ones, these are going to be the totals. We'll change the loop so that we do a take now on the totals. So this should be quite some interesting data that we get in here. We're very nearly there now. And yeah, well, definitely some interesting data. So I know now I said the word Tomcat 93 times on that course. I said Wozniak. I'm sure that's a typo in the subtitles. Yeah, some executions ID. Some very interesting things in there, but a lot of them just have a low count, so they're going to not be part of the big results. Now remember, we're only taking a sample of the data here, so we're only taking 50 of these results. There will be some bigger counts elsewhere in the data. What we really need to do is now sort these so that the most popular terms are at the top. If you were trying this for yourself, you'll have needed to use the reference manual. What we can do is we can do a sort. Now on a pair RDD, we can only sort by key. So that's no good really. If I call sort by key, that's going to give us a new pair RDD, which is going to be a string and a long. And then we'll do a take on the sorted. We'll do a take on the sorted pair RDD. This isn't going to be what we're looking for. Because of course what we've got the RDD sorted alphabetically. And in fact our bad data there, which is the blank one, is right at the top. That's not what we want. We want to sort by value, but there was no sort by value. So what can we do? The answer is in this totals. We could just switch the key and the value before we do the sort. And we'll do that with a simple map. So after doing this switch, we're going to end up with a long comma string. I'll just call this switched. So we'll take our totals and we'll map them. So for each element, which is going to be one of these tuple 2s, this is going to probably be a bit sticky. Given this tuple, we want to return a new tuple, which is going to be of type long comma string, so the other way around. And the values inside here, and this can hurt your head, especially, I'm recording this at nearly midnight, so this might hurt. I'm going to, in the tuple, I'm going to take the second value, so this is the _2, and for the second value, I'm going to take out the first value from the original tuple. So I hope that made some kind of sense. I'm just switching the two values around in the new tuple, which is going to build this new pair RDD. I have a compile error again. I think it's just because I should have said tuple 2 there. No, still a compile error. Oh, and of course the compile error here is I'm not doing a map. A map will just give me a regular RDD. I should have said, I'm sorry if that confused, I should have said map to pair, because this will be a pair RDD. It can be quite difficult to keep a track of all of these types. So I now want to do a sort by key on this switched RDD, and compile error. Hope you can work out why that compile error, because the types have been switched. So this will be long comma string, and now on the sorted I need to take 50. Again, same compile error here. We need to switch those types around. So I think that's quite hard work and took longer than I thought, but I think we're going to see some good results now. Oh no, that's not looking good at all. Lots of boring words and they're all just ones. Why has that happened? Is it something horribly wrong that we've done? No, it isn't really. You would just have to look at the documentation for sort by key. In fact, if I hover over the parameter list here, can you see that one of the versions of sort by key is whether you want the sort to be ascending or not? Now, the default for that is true, meaning that we're sorting ascending. So the lower values are going to come out first. We want it in the other direction. So the answer then, if we pass a false into here and run again, well, this is superb. The requirement was to get the top 10 keywords for the Docker course. And, well, apart from one bad piece of data in there, Docker is the top keyword, which is good. It's what we'd expect. We also have Swarm, Tomcat, Fleetman, Compose, Web App, Spring, Maven and Microservice, Eureka. These are all very relevant words to that course, and that's come out really well. Well, I think to finish off then, we ought to tidy up this bad piece of data here. And as I say, it's purely as a result of doing the splitting on words here. I'm guessing some of the words have double spaces in them. So that's causing some words to pop out which are actually empty. Now, I could improve this by reworking it, but as I said in the introduction, we're not going to worry about performance for this exercise. So I think I'll just do a little fix here. Rather than reworking it, which is going to look pretty confusing, blank words removed. So we'll do that by taking just the words. We'll do a filter. So given a word, we only want where the word, after we've called trim, its length is greater than 0. And then as long as we use this RDD on the next operation, and we may as well now change this take to just be 10. We just want the top 10 keywords for that course. And there they are. You'll notice there's another input file called input-spring, which I've just added in there for a little bit of extra interest, I guess. This is a slightly bigger course. It's a Spring Framework Fundamentals course, I think. If I just change the input file, let's see if we get reasonable looking output for that course. Spring, Deo, Hibernate, AOP, JDBC, etc. Looking pretty good. So this isn't perfect, and as I said, you didn't need to consider performance in this example, but we will return to talk about performance a little bit later on, and we'll probably use this exercise as a sort of motivating example. The most suspicious thing, I think, is using this boringwords.txt. Now, I've loaded that into the driver. I've not only loaded that into the driver, but it's also, in this line here, it's been sent across to the worker nodes as a serialized function. So we'll think about that a little bit later on. It's quite hard to teach these kinds of things because in real life, of course, you spend ages building these things and you have lots of dead ends and you struggle and tear your hair out and eventually you get the data in the format that you want. So I certainly wouldn't expect anybody just to roll this off the top of their head. And I've certainly spent quite a long time practicing this and getting it correct. Now, in the next chapter, I'm going to talk a little bit about some misconceptions about sorting that I've been able to avoid on this chapter, but it's a kind of a common mistake for newcomers to Spark. So we'll have a look at that in the next chapter. If you got this far, well done. I'll see you then.